Good morning. I am Vignesh, second year from IoT department. Today in this presentation, I am going to tell about the simulation of push button and LED with an ARM controller using Proteus. In this experiment, we will see how to interface a digital input, which is a push button, and a digital output, which is an LED, to an ARM based STM32 microcontroller. We will also simulate the entire circuit in a Proteus to verify the working. The aim of the experiment is to interface the digital output LED and a digital input push button with an ARM development board and to simulate their experience. Basically, when we press the push button, the LED should blink, showing how the microcontroller reads the input and responds this output. Now, coming to the components required for this experiment, we need STM32Cube IDE to write and compile the embedded C program. Secondly, we need Proteus 8 simulator to simulate the circuit virtually. Thirdly, we need STM32F401 ARM Cortex M4 controller as our main controller, a push button for input and an LED for output. As you can see, the STM32Cube IDE is used to develop the code, and Proteus helps to us to test without needing a physical hardware. So we only require the first two softwares. Now moving to the theory part, now let's see the theory behind this. ARM stands for Advanced IRSC machine, which is used to reduce instruction set for high performance and low power. The STM32F401 is based on the ARM Cortex M4 processor. It has 256 KB flash memory, 64 KB RAM and several GPIO pins that can be used for inputs and outputs. In this experiment, we configure one GPIO pin as input for push button and another GPIO pin as output for LED. When we press the button, the ARM processor reads the input signal and turns the LED on or off through the output pin. Now let's see what are all the things to be done in STM32 and Proteus. Firstly, open STM32Cube IDE and create a new project. Then select the target microcontroller, say STM32F401XC, and after naming the project, the IOC file will be automatically generated. The next configuration window, set the GPIO pin PA13 as input for push button and another pin PB0 as output for LED. Finally, save the configuration and STM32 will automatically generate the base C code for you. Once the project is created, we can now write our logic in main.c file. We will add the function and read the push button input and control the LED accordingly. After that, we build the project, check for errors and generate the .x file. This .x file is what we will load into Proteus for simulation. It's like compiled version of our program that runs inside the virtual microcontroller. Now let's see the Proteus simulation. For Proteus simulation, open Proteus and create a new project. Place the STM32F401 microcontroller, the LED and the push button. Double click on the microcontroller. Under the program section, browse and load the .x file that is generated by the Cube IDE. Now when running the simulation, pressing the button should make the LED blink just like it would in real hardware. Now let us see about the C program used in the experiment. We include the necessary header files, initialize the HAL library and system clock, and configure GPIO pins. In the main loop, we keep calling a function named push_button off. Inside that function, the program continuously reads the status of the push button using HAL_GPIO_read off pin. If the button is pressed, it turns the LED on and off with a small delay. If not pressed, the LED stays off. So basically, this code implements the logic that whenever the button is pressed, the LED blinks at the 500 millisecond interval. Now coming to the output and the result. In Proteus, when we simulate the circuit, we can see that the LED blinks whenever the push button is pressed. When we release the button, the LED turns off. This verifies that the input and output interfacing works correctly. So the result of this experiment is that we have successfully interfaced a simulated a push button and an LED using ARM STM32 controller in Proteus. To conclude, this experiment helps us to understand how a microcontroller interacts with an external component using digital input and output pins. It also gave us a practical experience with STM32Cube IDE and Proteus simulation. This foundation for more advanced embedded projects involving sensors, motors, and a real-time control. Thank you.